Okay, 6.8a. For this lesson, we're going to find all intercepts, minimums, and maximums given graphs, or we're going to have to graph them with our calculator. All right, so intercepts. Intercepts are where it crosses the x-axis. Those are our x-intercepts. Y-intercepts would be where it crosses the y-axis. And then the other things we're going to look at is local max and mins. Okay, now you have what's called an absolute max, which is going to be the absolute highest point of a graph. Okay, same thing with absolute min, the absolute lowest point. Now we have these things called local minimums and local maximums though. Okay, so we're talking about specific areas of a graph. Okay, but again, for a local min, basically you're looking for a low point. Okay, and when you're looking for those, you're looking for a turning point, okay, where it's going from up to down or down to up, either way. So when we're looking at this, it's just a random graph here. A low point, okay, a local min, you're going to be going down to up, okay, so a local minimum would be there and there. So those are local mins. And when I ask for local minimums or local maximums, all I'm looking for is the y-coordinate of that point. All right, so for a local max then, you're looking for a high point. So we're going from up to down. And in this case, I have two of them. And again, when I ask for these, I am just looking for the y-coordinate of that point. All right, so basically the big thing is look for those turning points, and that's where your local mins or maxes happen. So to start, I'm going to be giving you the graphs, and you're going to estimate those x-intercepts, those local max and mins. Okay, and then we're going to find the lowest degree possible for that graph as well. So if we look at the first one, x-intercepts, that's where we are crossing the x-axis. So we got here, 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 and here. We got 5 of them. Now, when I ask for an x-intercept, that is a point. So when I ask for these x-intercepts, you need to write it as an ordered pair. So for that first one, I'm going to work from left to right here. Okay, -1, -2, and it goes a little bit beyond that. So I'm going to say -2.1. Okay, and for an x-intercept, that y-coordinate is always 0. Okay, so the next one, -1, and then just a little bit beyond that. It looks like it's a little further than that other one, so I'm going to say -1.2, 0. Okay, that next one looks like it goes through the origin, so 0, 0. Next one, 1, a little bit beyond that, so I'm going to say 1.2, 0. And then finally another one that I would say 2.1, 0. Now, since we are estimating, I'm not going to be exact with these, obviously, so you got to get within a range of what I'm asking for. So like with that -2.1, you know, I'd probably accept -2.2, but if you said -2.0, that is something I would not, because it is beyond that -2. So basically, you got to get close. Like I said, I'm going to have a little range of numbers that you can be within. Now, for these x-intercepts, I could also ask them as zeros. Okay, so the difference between a 0 and an x-intercept is 0 is asking for that x value that makes the function 0. So in that case, for this one, if I ask for zeros, you're just going to write the x-coordinate of those. So know the difference between zeros and x-intercepts. All right, local max and mins then. Okay, local max, again, we're looking for a high point. So if I look here, there's a high point, there's a high point. Now, looking at those, okay, that local max, again, we're looking for just the y-coordinate. It gets to 1, 2, 3. It looks like it just touches it. Okay, so you can say 3. And again, just looking for that y-coordinate, that would be like -1.73. Okay, and I just want that y-coordinate. So 3, and then for the other one, you know, it looks like it goes a little bit above that halfway point between 1 and 2, so I'm going to say 1.6. All right, local minimums then. We got 2 of those as well. Okay, there it looks like it goes down between -1 and -2, a little bit beyond half, so I'm going to say -1.6. And that other one looks like it just barely touches that -3, so -3. Now I would accept -2.9 there and 2.9 for that max over there. But again, that's that little range that I'm going to be looking for. Lowest possible degree then. Okay, so if you remember from chapter 6, part 1, okay, looking at the turning points. Okay, so we got 4 turning points total here. And the turning points is always 1 less than the degree. Okay, maximum of 1 less than the degree. So I had 4 turning points, so this could possibly be a degree 5. Now, going beyond that, we could have some more turning points, but from what we're given, 4 turning points, so lowest possible degree would be 5. And also look at the end behavior. Okay, they're going in opposite directions, so if going opposite directions, that's an indicator of an odd degree, so it is probably a 5th degree polynomial. All right, looking at domain and range again. Domain, how far left and right can we go? Basically, what x values can we plug in and get something back? Okay, it goes on left and right forever. So again, x is the element of all reals. Range, then you're looking up and down. What y values can I get back after I do an input? Okay, and it's going up and down forever. So again, y is an element of all reals. All right, looking at the next one. Again, looking for those x-intercepts. Okay, so looks like it touches the x-axis there and there and there. Okay, they give us those specific values. Again, as x-intercepts, we are writing them as ordered pairs. So -2, 0 for that first one. Looks like 1, 0 for that next one, and then finally 3, 0 for that one. Okay, local maximums. Okay, high points. Okay, that x-intercept there looked like it was a high point. Same here. Now we got -3 there, and then it looks like, we'll just say -3 or +3 there. Okay, so what is the y-coordinate of those blue points that I have there? Okay, that x-intercept there, which is also that local maximum, -2, 0. So the y-coordinate of that would be 0. And then for that other one, we're just going to say 3. Okay, again, the y-coordinate for those max and mins. Okay, local minimum, looks like we got one of them. And it looks like it's just close to -3, but not quite there. So let's go -2.9. Okay, we had 3 turning points. So therefore, we should have 3 values for our local max and mins. Now, lowest possible degree. Okay, we got 3 turning points. And again, turning points is 1 less than the degree. Maximum number of turning points is 1 less than the degree. So in this case, 3 turning points. Lowest possible degree would be degree 4. Okay, domain looks like it's going left and right forever. So we're going to say x is the element of all the reals. Range, this is one where it's a little bit different. Okay. It has the highest point, okay, and it was at that local maximum right there. So whatever that y-coordinate of that local max was, that is going to be what's going to be in our range. And we said it was at 3, so we're going to compare y to 3, and it is below that, so we're going to say less than or equal to that 3. And again, domain is always dealing with x, range is always dealing with y. All right, so find all intercepts, minimums, and maximums using your graphing calculator. So what we're going to do here is you're going to go to your graphing calculator, and you're going to graph. Okay, and in order to graph, again, you go to your y equals. Okay, clear whatever you got there, and type it in. X, and you use the caret top to get your exponents, cubed, minus, oh, not times, minus 5x squared, plus 4x, plus 3. Go ahead, hit graph. There's our graph. And it looks like, okay, there's a little snapshot of it, and it looks like we got the right one. So when we're doing this, let's go ahead. Let's find zeros this time. Okay, so zeros, again, we're not worrying about writing an ordered pair, but we still need to find that x-coordinate of those points. Okay, so it looks like I got 3 of them. And in order to find those, again, second trace, and we are finding zeros. Okay, so let's work from left to right then. So that first one looks like it goes between -1 and 0. So let's use that as our left and right bound. -1 for our left bound, 0 for our right bound, and then x is equal to -0.46, y equals 0. So that is a 0. So we got x is equal to -0.46 for our first one. That next one looks like it goes between 1 and 2. So again, second trace, we're finding a 0. Okay, so we said goes between 1 and 2. So left bound, right bound, get y equals 0. So that is a 0. X equals 1.761. And finally, that last one looks like it goes between 3 and 4. So second trace, finding that 0, it goes between 3 and 4. And y is equal to 0. So x is equal to 3.7. Okay, crosses through the x-axis 3 times, so we should have 3 zeros. All right, finding those local max and mins. Same idea here. Okay, so second trace, and now we're going to find our mins and maxes. So let's go ahead, let's find our minimums first. And it looks like we have one of them. Okay, so now with these, it's going to be a little bit different on the calculator. I'm going to find another video that has the TI-84 interface. So make sure to watch that video too if you can't follow what I'm doing with this video. But on this one, that minimum, and again, it goes from down to up. It looks like it goes between 2 and 4. So I'm going to use that as my left and right bound. So left bound of 2, right bound of 4. Now the calculator is looking for that lowest point in that range. Okay, so we got 2.87, negative 3.064597. And as you look at the calculator, it shows that point that you're actually looking for. So that's a good indicator that you found the proper point. So minimum, and we should say local min. Okay, local min. And again, we're just looking for that y coordinate. So negative 3 point, and let's go to the hundredths place, 0.6. Okay, we only have one of those, so now we got to go find our local max. Second trace. Okay, so max. And then that one looks like it's going between 0 and 1, so let's use that as our left and right bound. 0, 1. Okay, you see that point there, so we found it properly. And again, local max. Just looking for the y coordinate. Let's go to the hundredths place again. 3.88 for our local max in that case. All right, so that's all we need to do for that one. Calculating those zeros and their local max and mins. All right, so the next one, just go back into y equals, and then type in that function, 2x to the 4th minus 3x squared minus 2. Go ahead, hit graph. There it is. Okay, snapshot looks the same, so it looks like we got the right one. So let's go ahead, let's find those zeros. Okay, second trace, we're finding a 0. And for this one, it looks like it goes between negative 2 and negative 1. So there's my left bound and my right bound. It hits that point. So again, x is equal to 1.414. Let's go ahead, find that next one, second trace, finding that 0. Looks like it goes between 1 and 2. 1.414. So the fact that those are both the same, it's looking like this is going to be a symmetrical graph. So probably look for those with our local max and mins as well. So local min, looks like we have 2 of them. Second trace, minimum. Now it looks like it's really close to that negative 1. Now, so in this case, I'm just going to go negative 2 to 0, because I know that that minimum falls within that range. So negative 2, 0. And again, we're just looking for that y coordinate. So negative 3.12. Let's go ahead, let's find that next one. Second trace, minimum. Okay, I'm going to use a 0 to 2 in this case. 0 to 2, because that lowest point falls somewhere within there. And that one is, again, negative 3.12. Now, they're exactly the same value, but they are 2 separate local minimums, so you do need to write both of them, even though they are the same number. So again, local max then, second trace, maximum. And it looks like it happens when x is 0, so I'm just going to say from negative 1 to 1. Okay, and there's that highest point. Again, it shows it right on the calculator. Y is negative 2, so there is our local maximum. All right, so that is how you will find your local max, mins, and your zeros on your calculator. Again, if I ask for x-intercepts, make sure you're writing them as ordered pairs. For your homework in this one, okay, I want you to make sure you're finding x-intercepts, local max, mins, tell me the lowest possible degree, and then the domain and range for every one that you're doing in this one. Okay, it is 6.8a homework. Okay, so there's the graphs. Okay, we put some graphs in there so you can sketch it out to see if that helps, and then find those specific things I'm asking for in those ones as well. All right, if you have questions, make sure you let me know. Otherwise, have a good day.